Hello everyone, I am Dr. Hirokjyoti Bora, Assistant Professor of Assam Downtown University. In this video, I am going to describe one chemistry practical. The practical is iodometric estimation of copper in copper sulfate solution using sodium thiosulfate. Now I am going to giving you a brief introduction about iodimetry and iodometry. Iodine is a weak oxidizing agent. There are two types of redox titration involving iodine. One is called iodometric titration, in which a standard solution of iodine is used, and it is also called direct method. The second method is called indirect method or iodometry or iodometric titration. In this method, iodine is liberated from an iodide by a strong oxidizing agent in acidic medium. The liberated iodine is then titrated against a strong reducing agent. The reducing agents used are sodium thiosulfate, sulfurous acid, stannous chloride, hydrogen sulfide, etc. They react quantitatively with iodine in acid solution. The oxidizing agents are permanganate ion, dichromate ion, copper 2, iron 2, etc. The pH of the system should be below 8. Now, I am going to explain the theory of this experiment. In this experiment, copper 2 ion oxidized iodide ion to elemental iodine. The liberated iodine is titrated against a standard sodium thiosulfate solution using stars as an indicator. This is the reaction between them. Now I am going to requirement of this experiment and its preparation. One requirement is 0.1 normal sodium thiosulfate solution, and it is also called hypo solution. We prepare sodium thiosulfate using 25 gram of sodium thiosulfate and dissolve it in 1 liter still water. Another requirement of the experiment is standard 0.1 normal copper sulfate solution. This is the method for preparation of copper sulfate solution. Another requirement is copper sulfate solution. You just remember that the difference between these two copper sulfate solution is this copper sulfate we use for standardization of 0.1 normal sodium thiosulfate solution, and this copper sulfate we use for determination of copper in this solution. Another requirement is 2 normal acetic acid, 10% potassium iodide solution, sodium carbonate, stars indicator, and ammonium thiocyanate. Now let's go to the procedure of the experiment. Okay, so in this experiment we used 0.1 normal sodium thiosulfate. This is called hypo solution. Now since sodium thiosulfate is a secondary standard solution, therefore we have to standardize this sodium thiosulfate solution using 0.1 normal copper sulfate solution. This is the sodium thiosulfate, and this is 0.1 normal copper sulfate solution. We for standardization of sodium thiosulfate or hypo solution, we take the hypo solution in burette. We fill up the burette to 50 ml. Now we take the copper sulfate solution, 0.1 normal copper sulfate solution in conical flux. Now we take 0.1 normal copper sulfate solution in conical flux using pipette. This is 25 ml pipette. This is copper sulfate solution. So now we titrate copper sulfate solution by hypo solution, and for this experiment first we add sodium carbonate to copper sulfate to neutralize the extra amount of sulfate. This is sodium carbonate, and we adding just small amount of sodium carbonate. So this is small amount of sodium carbonate. Now we add a drop of 6 normal acetic acid. This is 6 normal acetic acid in small beaker. Now we add 20 ml of 10% potassium iodide solution. Now we keep the reaction approximately 5 minutes. After 5 minutes, now we titrate this solution using hypo solution for some times. Now we add stars indicator, approximately 2 ml. After adding stars indicator, we again titrate the solution using hypo solution. So we titrated this solution. Now we add potassium thiocyanate to this solution, and now we again titrated this reaction mixer against hypo solution. Now the color of the solution changes to blue. The colors change and it becomes light blue. Now see, the color of the solution completely changed. That means the liberation of iodine is completed, and this is the end point of the solution. And from the end point of titrant, we calculate the strength of hyposolution. Now, after standardization of sodium thiosulfate, we repeat the procedure with 25 ml of copper sulfate solution using standardized sodium thiosulfate solution. In this way, we determine the amount of copper sulfate present in copper sulfate solution. Now I am going to the calculation part. First, we calculate the strength of sodium thiosulfate solution using this equation. Now this is normality equation. Here N1 is normality of sodium thiosulfate, V1 is volume of sodium thiosulfate, N2 is normality of copper sulfate, and V2 is volume of the copper sulfate. Using this equation, we can calculate the normality of sodium thiosulfate solution. After calculating the normality of sodium thiosulfate solution, we calculate the strength of copper present in given copper sulfate solution using this equation. So in this way, we can determine the amount of copper present in copper sulfate solution. Thank you.